There's a moment every person knows. You're pushing hard. Maybe it's a run you didn't train enough for, a set of pull-ups 2 reps past what felt possible, or a project you've stayed up too late finishing for the third night in a row. And then something speaks. Not out loud, not in a voice you can point to, but the message is unmistakable. Stop. You've hit your limit, and almost every time you listen. What's strange is this: most people never ask where that voice came from. They assume it came from their body. They assume their muscles gave out, their lungs protested, their nervous system filed a complaint. But what if the signal didn't come from your body at all? What if it came from something that, for its own reasons, decided you were done long before you actually were?
In the 1990s, a South African sports scientist named Tim Noakes started noticing something strange in the data. Elite endurance athletes, people who had spent their entire lives training near the absolute edge of human performance, were not failing when their muscles ran out. They were stopping while substantial energy reserves still existed. They were stopping while their oxygen levels were still compatible with continued effort. They were stopping, in other words, while they could still continue. Noakes was a cardiologist and exercise physiologist who had spent decades studying why humans quit. And the data kept pointing in the same direction. The body wasn't stopping the athlete, something else was. He called it the central governor. The idea was straightforward but almost impossible to believe at first. The brain, Noakes argued, doesn't wait for you to actually fail. It predicts failure in advance. It monitors your blood oxygen, your core temperature, your muscle glycogen, your heart rate, and long before any of those systems actually reach a dangerous threshold, it begins generating the sensation of exhaustion, not real exhaustion, the feeling of exhaustion. The difference between those two things is enormous. Real exhaustion is a physiological state. The feeling of exhaustion is a neurological broadcast, and the brain sends that broadcast deliberately, like a security guard who locks the doors 30 minutes before the building actually closes. The question is why? Why would the brain betray you that way?
Here's where it gets uncomfortable. Your brain was not designed to help you perform. It was designed to keep you alive. And those two objectives are not always the same thing. For the vast majority of human history, pushing your body past its comfortable limits was dangerous. A hunter who ran until total muscle failure couldn't escape a predator. A human who ignored pain signals until they turned catastrophic didn't survive long enough to become your ancestor. So the brain built a safety margin, a buffer zone between where you actually are and where you feel like you are. And that buffer zone is surprisingly large. Research examining perceived effort versus actual physical capacity has repeatedly found that when most people reach their subjective limit, the moment they are certain they cannot continue, they have typically used somewhere between 30 and 40% of their actual physiological reserve. That number is not a metaphor, it's not an approximation. When your brain tells you that you're done, your body still has more than half its available resources untouched. Now think about what that means. Every time you stopped when you felt you couldn't go on, whether that was physical or mental or somewhere between the two, you weren't at your limit. You were at the boundary your brain had drawn to protect itself. You were inside a cage you couldn't see.
David Goggins figured this out without a lab coat or a research grant. He figured it out while running 100 miles through the night on shattered knees. He figured it out while doing over 4,000 pull-ups in 17 hours. He figured it out in a Navy SEAL training program where the attrition rate was around 75%, and where the majority of candidates who quit were physically capable of continuing. The body wasn't quitting, the brain was quitting, and Goggins started treating that quit signal the way Tim Noakes described it, not as a fact, but as a forecast. Not as truth, but as a very conservative early warning system designed for a world that no longer exists. He wasn't ignoring pain, he was reinterpreting it. Here's what neuroscience has to add to that. Pain is not a simple alarm system. It's not a direct readout of tissue damage the way a thermometer reads temperature. Pain is a construction. It's your brain's best guess about whether something is actually dangerous, based on context, expectation, history, and current threat level. Soldiers have reported finishing firefights without noticing serious injuries. Athletes have broken bones during competition and kept playing. And laboratory studies consistently show that the same physical stimulus, identical in every measurable way, produces dramatically different pain responses depending on whether the person expects it to hurt. The brain doesn't just receive pain signals, it edits them. It amplifies signals it considers important and suppresses signals it deems acceptable, based entirely on its current interpretation of the situation. This is why a parent in danger can lift a car, not because their muscles are superhuman, because their brain briefly removed the safety governor. And this is what makes the central governor theory so unsettling. If the brain creates the feeling of exhaustion as a protective mechanism, and if that mechanism fires long before you're actually in danger, then the question becomes, is the limit real? The answer, according to the research, is, it depends on whether you believe it is. In 2012, a study had cyclists perform a time trial while secretly watching an avatar they were told represented their previous best performance. When the avatar was quietly sped up to a pace slightly beyond what the riders had ever achieved, the riders matched it, unconsciously, achieving performances they would have said were impossible. Their bodies didn't change, their belief about the limit changed, and the brain adjusted accordingly. This is not mysticism, this is not motivation, this is the basic architecture of the nervous system, a prediction machine that calibrates your performance based on what it expects to be possible. Change what it expects and the performance changes. Goggins understood this intuitively. His concept of callusing the mind, the deliberate, repeated exposure to discomfort, is not just a philosophy. It's a systematic rewiring of the brain's prediction model. Every time you push past the signal, you teach the brain that the signal was wrong. Every time you prove the forecast inaccurate, the threshold shifts. The cage gets bigger, but here's the part that stays with you. This doesn't only apply to running or lifting or military training.
The same mechanism, the same central governor, the same early warning broadcast, the same protective fiction your brain generates about your limits, operates in every area of your life. The moment you feel like you've been working too long on something difficult, the moment a conversation becomes uncomfortable and you want to leave, the moment a project starts to require more from you than feels sustainable. That signal comes from the same system. The brain monitoring the situation, predicting difficulty, broadcasting a feeling that is designed to make you stop long before stopping is actually necessary. And the uncomfortable truth is this: most people spend their entire lives operating inside that signal, never questioning it, never testing whether the boundary is real or constructed. They feel done, so they stop, and they never discover what was on the other side of that feeling. There's a word in neuroscience for the brain's ability to accurately monitor the body's internal state: interoception. It's the sense that tells you when you're hungry, cold, tired, anxious, or in pain. And interoceptive accuracy, how closely your perceived state actually matches your physical state, varies enormously between individuals. High-level athletes, meditators, and people who have spent years exposing themselves deliberately to discomfort tend to have better calibrated interoception. They feel what's actually happening rather than the amplified, conservative broadcast that most people receive. They've trained themselves to read the signal more accurately. And what they find consistently is that the actual limit, the real physiological wall, is much further away than it felt. The brain quits long before the body does. It has to, that's what it was built to do. The question is whether you'll always take its word for it. There's something almost liberating about understanding this, not because it makes hard things easy, but because it changes what hard things mean. The discomfort isn't evidence that you're failing. It's evidence that the system is working exactly as it was designed to. The signal fires. What happens next is up to you. Every person who has ever pushed past a point they were certain was their limit has discovered the same thing on the other side. Not a superhuman capacity they didn't know they had. Something quieter than that. The realization that the voice telling them to stop was not a fact. It was a prediction, and predictions can be wrong.